Hello everyone, this is the Laser Wizard, and today we are reviewing the FoxAlien 3018 SE CNC router along with their CNC Mini-Vise, their set of end mill bits, as well as their triangle bits. So let's start off with the CNC router. Okay, this looks like the front door possibly. Right acrylic sheet, maybe not. Left acrylic sheet. Pretty beefy. There we go, front acrylic sheet. And back acrylic sheet. Another clear one. Top acrylic. A sheet of plywood. Ooh. We've got the packing list along with probably the instructions, as well as all the goodies. Let's probably take the delicates out first. So this control board here is unlike any other I've seen on Amazon or eBay. So it seems to be quite unique to FoxAlien. Alright, next up, power supply is rated for 12 volts, 5 amps, so about 60 watts. We've got a wiring harness, very clearly labeled. USB cable. Right here looks like they include a spare limit switch. We've got what looks like to be all the hardware we're going to need. Some pads, nice thick clear acrylic. Wow, an entire toolkit. Very long torque wrenches. I'm assuming a brush for cleaning the screws. Metal brackets. Ooh. Much larger hardware. Oh, I believe this is the Z probe. Cooling fan. And probably what triggers the limit switch. Hey, it comes included, comes with some bits. I believe this is the handle for the door. Got an emergency stop. bunch more brackets. And thumb drive with hopefully all the stuff we need on there. Next up is the gantry. Looks like it's mostly there. Power cord is shoved in here. Got a power cord. So we'll take a closer look at the gantry in detail once everything's unpacked. Okay. Oh no, we got steppers in here. Got some nuts. So I gotta say, I think it's pretty well packaged. It's reinforced on all sides with some 1/8" plywood. But I mean, this will really help stuff puncturing through the box if it knocks into something else that's sharp. We gotta do a little bit of cleaning on this one. The bed looks pretty flat. So here we are, FoxAlien. So let's start taking a more in-depth look at each of the individual components. Step 1 of assembly is the X-axis stepper motor, and for that we're going to need the gantry one of the stepper motors, and 4 M3 by 12 bolts with washers. The first step is very straightforward. You're going to grab your stepper motor, and with the plug you're going to face it to the rear of the machine. I have the gantry laying on its back so that faces down. You want to make sure that your D shaft is facing to where your set screw is, and you stick it in, and you got to make sure that the flange falls into the hole, and then just put the screws in. You want to make sure that you snug up all the bolts that hold down the stepper motor, and you want to do that before you torque down the set screw for the shaft. And that's because on the other side the screw is already bolted down to the bearing and it cannot move. So you want to make sure that this motor, the stepper motor, is where it needs to be before you tighten that screw. Once you've got all the bolts torqued down, now you can torque the set screw. You should always be very careful and check every nut and bolt and every axis. I like to give everything a shake, and I noticed that on the other side here, these aluminum, or should I say, I'm sorry, steel guide rails, they're not actually bolted down tight. What I would recommend is that you manually spin the Acme screw and move the carriage all the way over to the end. That way the spacing between the bearings is good, and then I would tighten these. We're going to check over the bolts on the other side. We move the carriage all the way back to the stepper side, and they're also pretty loose. And with a lot of work and vibration, these will for sure loosen up. So make sure you go over all your bolts, even the pre-assembled ones, and tighten them down, and make sure everything spins freely. The same thing goes with these extrusions. I give them just a little bit of extra torque. Next step is to assemble the Y-axis. For that you're going to need pre-assembled Y-axis. Also, it's the bottom of the machine. You're going to need the other stepper motor, 4 of the M3 by 12 bolts with their washers, and for this here, we're going to actually have an additional step because, unlike the gantry, the Acme screw is actually not torqued down in the bearing here. So we want to make sure that that is set in there. So we're going to do that first. And the way you do that is you just take this off. We're going to have to pull this back, take it off, move this over, and I'm setting mine where it's about flush on the end here. That seems to be the sweet spot. So make sure those are nice and tight. There's 2 of them. And now it does not budge. Now we can slide it back in, put the bolts back in, and make sure they are nice and tight. So now this is set. Now that our set screw is tightened down, we're gonna do the stepper motor. If we have the front of the machine like this and upside down, and the limit switch stops are here, the wire plug goes this way, away from where these are. And I have set the flat on the stepper motor to be up, and I've set the screw to have its set screw facing up. There's screws on both ends, so first you want to set the D shaft screw, then the other shaft side. And just like before, you want to bolt the motor in first before tightening down the set screw, or else you might be binding the motor if everything's not lined up properly. And make sure they are tight, but don't strip them. I don't have a torque spec to give you, just make sure it's good and tight. And now that the stepper motor is torqued, we're going to torque down the set screw for the shaft. Let's confirm that this one is tight as well. Yep. Flip it over. And there we are. Step number 3 of the assembly process is to put the gantry to the y-axis. You're just going to need 8 of the M5 by 14 bolts. So FoxAlien has already saved the issue of aligning the gantry, because that has to be absolutely square, and they put these blocks in here to act as stops on both sides. So hopefully those are accurate, but we'll confirm that. And there's tests that you can do and then measure to confirm and then readjust if needed. And these nuts in here, I tried my best to line them up. You may have to move them around to get them in. But we'll see how it goes. Okay, we got one in. Okay. Now we're going to leave those finger tight. I'm going to carefully rotate this. Okay, now that they're in, we're going to make sure that the gantry here is very, very tight, that there's no gap. You see that? We want it to be nice and straight. We'll do that in stages, slowly and carefully. Not too tight at first. So you see the gap there? We gotta make sure that gap is tight. So we want to make sure that all the bolts, once everything's lined up, that then we give it a good final torque. And again, don't overdo it, don't crack it. This is acrylic. You might strip it, but you definitely don't want it to wobble loose. Here I already tightened some of these. This one's loose. And this one should be tight. So gantry seems very nice and rigid. And boom, just like that, it's already starting to look like some sort of a machine. It doesn't wobble at all. Everything's very sturdy. And I mean, a little bit of flex on the rods here, but that's expected. This is really meant for engraving. Part 4 of assembly is the main board. This one is held on with T-nuts that go into the channels here in the extrusions, and you have to be very careful because they are not spring-loaded. You have to first loosen the bolt a little bit, and you have to make sure that this thing will turn and be perpendicular and locked in this shaft. But as long as you're careful and pay attention, it shouldn't be too big of a problem. I have the main board bolted down nice and rigid. The next step in the instructions is the case assembly. Later when we do the wiring, we may need to loosen up the bolts and adjust this just to get the wires to fit snugly. First step in assembling the case is to grab the left acrylic sheet and peel off its covers. So it came with 8 of these spring-loaded T-channel nuts. I'm going to use these for the 2 side acrylics. I really don't see where else these are used. They will make the process much easier. I'm leaving the side panel just loose for now. I'd rather have everything put together loosely, settled in, and then we'll tighten it all at the very end. Before we move on to the right side, we're going to install the magnet suction bracket for the door. I'm going to use 2 M3 by 12 bolts. Part 7 of the assembly is the right side panel. That's the acrylic sheet with the hinges. First step is to get all the tape off both sides. Alright, right side panel assembly is pretty straightforward, much the same like the left side. Make sure you use the blocks and you put nuts in the channels. Next step is to install the emergency stop switch on the right side panel. And you do that with 4 M4 by 12 bolts. Part 9 of the assembly is the door handle. You first have to take off the bracket back here. Put the handle in. And carefully put these right back in. Part 10 is assembling the front panel to the hinges. Make sure that the magnet is facing towards the machine. Part 11 of the assembly is the cooling fan. It's the fan that cools the control board. Most importantly, the stepper motor drivers. You're going to need the back panel, cooling fan, and 4 M4 by 8 modified truss screws. So it turns out that the position of the control board is dependent upon the back panel because of the cutout for the power switch. So we're going to have to line the control board such that that power switch is right where it needs to be. So once we got it where we want it, tighten the bolts. Now before the back panel goes on, we have to do all the wiring, and here's where the instructions are a little lacking. They show you a diagram of what all the connections are, and kind of leave it up to you to make all the connections. So I'll step through the process, hopefully make it pretty simple. We're going to start off the wiring with the X-axis motor. One side is a 4-pin connector, the other side is a 6-pin. The 4-pin one plugs right in here to the X stepper. And then for now, we're just going to feed it right through this hole. And we're just going to leave it just like that for now. Next is the Y motor. This one, same thing. And there's 2 positions for the Y motor, and one is mirrored on the other. So we're going to try this one first, but if the Y-axis moves opposite of what we like it, then we'll just flip it over. And we're not going to plug this one in just yet. It needs to go through the hole in the back panel, so we'll let that dangle. And then the biggest hunk of wiring harness here is for the main Z-axis. Got the spindle, those Z limit switches, One side is this one, goes over to the spindle. This side, we're gonna grab the Z motor and we're gonna plug it right into where it says Z step. This one here that says spindle, that goes in where it says laser on here. At least that's as far as I'm concerned. This switch here dictates how it treats that output. This is the Z limit switch, which is 1, 2, 3, 4, 5. It's the 5th one over. 1, 2, 3, 4, 5. And that goes right in here. We're gonna have to see if we can clean this up somehow, but we got this half all plugged up. We can already plug in the Z motor. It's this one right here. And we're gonna need to make sure that this can move freely as this is traveling side to side. From the bottom, we've got the Y limit that goes to the left of the Z. The X limit goes to the left of the Y limit. And for now, I believe the E stop goes in the reset. The main Z-axis wiring is pretty straightforward. Minus for the spindle goes over here. And then you've got positive labeled where the positive goes. That way your spindle's not spinning backwards. And you want to make sure that these are on and they're on there good so they're not arcing. And then the last part are the Z-axis limit switches, and there's 2 of them, and they plug right in. For the E-stop wiring that's on the right side panel near the front, we want to connect it to the common, which is C, and then normally open connection. That way once we push the button in, it closes the circuit and stops the machine. So polarity really doesn't matter. As long as you get them in there right. On the back, we're going to want to connect the X-axis stepper motor plug. Make sure that's in there good. And then down here is a plug that needs to be connected for the X-axis limit switches. The amazing Z-axis probe has another 2-pin connector, and that goes just to the right of the Z limit switch connector. And we're gonna snake it to the front of the machine just like this for now. One of the last things we're going to plug in right before putting the back panel on is the USB cord, and the more square end is going to go right in here, and then we're going to feed this through a hole in the back panel. We're just about ready to put the back panel on, but and I can't stress this enough, you have to go over all these bolts and make sure they're tight. Now, I already did that on mine, but these are the bolts for the guide rails for the Y-axis, as well as what holds the extrusions together. Make sure all those are tight, front and back. power cord gets fed from here, plugs right in. Now it's time to put the rear panel on. I'm going to take the USB cord, feed it through this hole here. We're going to take the Y motor stepper connector and feed it through this hole here. And then we're going to have to plug the fan into the very first connector in the row here, right next to the e-stop plug. Now that everything's plugged in, we're going to need 2 more acrylic blocks and then 4 of these big bolts. So I was curious why I couldn't get that bolt through that one hole. It goes here nice. Here, it's still in there. I believe, I don't know if they're using a laser or a water jet to try and pierce through these. So I'm going to try to hammer that out. Well, luckily I was able to punch it out without completely shattering it. It's still completely usable. I just used a punch and a hammer and a vise. But this piece went shooting out, so be very careful if you have to do something similar. Luckily only one of them had that issue. Once you've got the back panel on, then you can plug in the Y stepper motor plug into the stepper motor. And then you can carefully feed this cord back in here. Next we're going to install all the little corner brackets using M4 by 12 bolts with washers. And then for the top panel, these get installed like so. Try to keep them as straight as possible. And what I believe is the final part of the hardware assembly is the top panel. It's nice and clear so you can see all the screw-ups you can do to perform on this machine. Looks like I'm going to have to loosen this one and readjust it. Just loosening it here a little bit Got this one up here to catch. One little detail is these panels don't match up, so we're going to loosen those bolts and we're going to readjust it, so hopefully it's nice and flush. Alright, that is now very nice and flush. The software installation went very smooth for me. On the USB stick that comes with the machine, there's a zip file. I used WinRAR to extract it. And in the folder, they have a Mac folder and a Windows folder. This is a Windows, so I go onto here. The whole manual is on here. We've got software here. So first thing we would need to do is install the CH340 driver. That's for the Arduino chip that's on the board. I've already got that installed on my computer, but that's why it's failing for me. But for you, hopefully that'll go well. Right here is your GRBL control, which is candle, and I believe it works right off the drive. So what I've done is I copied this folder onto my main drive, and I've got a shortcut right here, and this is your main control board right here. So now you can plug in the actual machine, and what we really want to make sure and check is if we go into Device Manager, you have to look under ports, and right here CH340 is on COM5, and usually everything is set by default where it needs to be, but if that becomes an issue, then you need to change it or refresh it right here. But there's two options here. Make sure it's on the one that we just checked. And then from here we've got our jog operations, forward and back. Before the machine can get used, you need to unlock it with this button here. And now we can go forward and back, side to side, and up and down. I'll make a later video that goes into much greater detail how to use the software, how to zero out the axes, and how to use the probe. But from here you just load the files. It comes with a few files on the drive, which I believe I've actually put here. And if you go to test code, they have a good few options. Now, some of them may not work right out the box. I have to modify the Dragon file here. What I've actually had to do, if you open up the Dragon file with Notepad, this is the Dragon here, but if we open it up with Notepad, then the feed rate up here is set to 300 millimeters a minute, and then there's a mistake here. The S value here is set to 1000, and I'll show you what happened the first time I tried to carve this file. So the way to solve this, you add one extra zero to the end there, and what I did, I changed this feed rate to 150. Now, maybe 300 might be fine. I didn't try it yet. I set it to 150. It took about 6 hours to do the Dragon, but it came out phenomenal. You'll see later. I definitely want to play with the feed rates. If it can handle 300, then they'll cut that time in half. But once you make your adjustments, let's say we want to try 200 for next time, then we go File, Save As, and then we're going to save it and call it 200 mm. And then that's the file that we can run when we load it in Candle. Alright, I'm going to attempt to carve out a logo into this piece of walnut using FoxAlien's Mini-Vise. There's not much Z-axis travel height on these machines, so it's very important. It's tough to get a good clamp in here that'll clear. So we'll see just how well this works. But this axis is already at its upmost position, and as it is now, this would not clear. So what we're going to do is we're going to raise up the spindle in its holder to give us as much room as we can get. I've already got that loosened, so I'm going to bring this up, and I'm raising it up until it's pretty much flush on the bottom here. And I'm going to tighten it back up. Now we can install the vise. It's got 2 T-nuts here. I'm going to stick it in this first channel here. So here's where you got to be careful. Sometimes the nuts don't catch the channel. So we're going to have to loosen it back up. Alright, that one caught, and that one caught. Torque it down nice and good. Okay, now this piece right here does not fit, so this is adjustable here. I'm going to loosen these. That was pretty good. Okay, now this slides around. So we're going to stick this on, butt this up. Torque these down. Now we can apply some torque to here. Alright, I think that sounds pretty good. So I noticed that as I was clamping this down, this piece right here started deflecting upwards and out, and even though it's held, it's actually up at an angle. But the way that you solve this is you have to snug these up first. So we're going to loosen this, and then the 2 bolts that are on top, we're going to just get them to touch. We're not going to torque them down, we're just getting them to touch. That way this can still move, but it can't budge up or down. And now when we torque this down, it does not deflect, and it is as level as it's going to get. Alright, now that our wood is nice and snug, we can flip the machine power on, and first thing we'll do is set the Z-axis height. So we're going to do that using Candle. I'm going to move it down. And you got to be careful that you don't snap your bit here. You got to make sure it clears. So we're going to step the steps lower. We're going to go 1 millimeter at a time. And we're just eyeballing. We're not doing anything high precision. And I'm going to bring the head down. It's going to help us zero it out. So I've gone a little too far already. But there we go. So I'm going to zero out the XY here. That brings our tip here. Now we're going to need to zero out the Z. The way we'll do that is I'm going to move it over. I'm going to use a piece of paper for now. Let's move it in here. I'm going to set the steps to 0.1. I'm going to keep clicking here until it catches this paper. And there we go. So I'm going to set the Z height right here, zero it. And now that tip is right level. So I'm going to bring this up, 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 up. And so we've got the machine zeroed in. Now we're going to load our file. And let's open up this one right here. Should take about 1:42. Only one pass. And hopefully at a good feed rate. So one thing I like to do is make sure that this will fit where we're cutting it, so you can move it, jog it over. You can physically look where you're at. You know we're at the right edge here. Maybe a little more. But it'll fit on this piece of wood. So now that we know it all fit, we can send it. But for that step, I will close the front door to keep any debris and possible mishaps from shooting out. So we've got the XY axis zeroed, we've got the Z axis zeroed. I think we are ready to send it. So I'm going to click send and hope for the best. And that looks pretty good. Look at that. Very smooth and straight lines. So I had the feed rate set to, I believe, 200 millimeters a minute. Obviously the slower the smoother, but I wonder what the limits are. I'm actually very happy with this vise. It kept this pretty square, even though I've not really leveled the bed. And the very neat thing is how easy it is to load material, and you can tighten it down with one hand and it's on there. It's not going anywhere. The alternative to using the vise are the regular clamps, and I'll show you just how much of a struggle they can be. However, FoxAlien's versions of the clamps are, I think, better than what's usually out there. And it's these right here. So if I wanted to clamp the same part, well, then I gotta stick this in here. And I don't want to mar my machine, so I've got these laser cut round wooden discs. I stick them under the bolt here. You want to make sure that this clamp is sloping down, but then you got to make sure it's by the tippy tip here. And let's try to get that a little bit further away. So some people put the bolt heads underneath since they do less damage, but they still have rough stuff, and so I've got these. Help keep it a little pretty. So you see, to engrave something on a small piece that goes over to the edges, that brings the spindle very close to the clamps here. So these clamps work great, and it comes with 4 of them. They're definitely better than what I've seen on some of the other machines. A lot of them don't have this counter lever on the other side. So having the vise, definitely a tremendous bonus. I've done a few cuts before, and I've spent most of the time on the setup was with the clamps. Opening the file and clicking send is the easy part. So there's an easier way to set the Z height, or a much more rapid way, and that's with the included Z Pro. And this is an incredible piece of technology. It is an aluminum block with a wire terminal on the other end. Doesn't need to be high tech. Sometimes the simplest solutions are the best. So this plate's hooked up to one terminal, and you use the alligator clip to touch your bit. And the moment this shorts out, it sets the Z height. And normally you'd like to measure this. Unfortunately, the only calipers I have here are only accurate to 1/10 of a millimeter, so we're at 15.0, and in the software it's at 15.04. But if you needed to change that, you go into settings, and under connection at the bottom for probe commands, there's a Z value, and my machine is set at 15.04, so I'm going to assume they measured it much more accurately than I have. So, as far as I'm concerned, you just click Z Pro, which is right here, and hopefully it works. It's coming down. There we go. That is amazing. It works. So, I have had this machine for just a little over a week and a half now, and I gotta really say I have learned quite a ton. I'm a total newbie to CNC. I've owned a laser CNC machine by FoxAlien for about a month now, and that thing is awesome. And I wanted to try out an extra dimension. So this is a 3-axis CNC, and there's definitely a learning curve, but that is the whole point of this machine here. This is something you buy to learn CNC on. You're not going to be making engine parts on here. You're not going to be decking engine blocks. The machine comes with some V-bits. Take a look, just like this, and you can do quite a bit with these. The very first thing I tried to do ever on here was one of the included files, and it came out pretty good. A little jagged, but the feed rate was quite fast on this one. Right afterwards, I tried to run it on anodized aluminum, and I was carving it, but a little jagged. It was way too fast for aluminum here. Later, I learned how to adjust feed rates, which I had to do for the best carving I've done so far, and that is the Dragon file that comes included on the USB stick. This is, honestly, this is incredible. The detail that it was able to dish out really caught me by surprise. Now, the way the file came would not work. I had to adjust the feed rate and the spindle speed in it. I'll cover that in a different video. But the detail, you can see the pupil and the eyeball of the dragon, the detail in the ball here, the waves, the scales. And what's incredible to me is these corners where the V-bit had to, make it flat. That means it went side by side very finely so that you don't see any machining marks down in those corners. I did a sign for me and my girlfriend. For this, I tried out their end mill bits. I did not snap any bits, but I have a lot more to learn to try these out, so hopefully in a later video we'll see what these things can do. But so far I did this, and then using an end mill and a V-bit, I did this logo right here. And I definitely got to get better at setting the Z-axis, especially between bit changes. I really like that they included a Z-probe. Such a simple device, yet saves a lot of time and effort. It makes zeroing the Z-axis quite easy, quite simple, and quite repeatable. So if I were asked if I would recommend this machine, definitely 100%. This thing is pretty gnarly. For the price that this thing costs, biggest thing I really liked about it, and the reason I went with them, is that it comes with a full enclosure. And to me, that is like essential, because I want to play around with feed rates. I want to maximize my speeds. I don't want to wait around. This thing right here, this took 6 hours to do. So if a bit were to snap, I'd rather there be some acrylic between me and that bit rather than it just shooting out. I plan to add a vacuum suction right at the tip, as well as possibly a dust collection to the enclosure. And the fact that it's already all enclosed really makes that much easier. And for the price, I'm surprised they were able to afford to include it. One of the biggest benefits of this machine is the customer support. I see a lot of people complain for a lot of the much cheaper machines out there that there's no instructions and no customer support. There's other companies that are pretty big, but they're so busy it takes time for them to get back to their customers. FoxAlien has answered all my questions, and believe me, I've had a ton ever since I got the laser machine. And I knew that I could buy this machine with confidence, and any issue I had, they'd resolve it. They also have a Facebook group page, very active, and people post problems there from time to time. They get answered. Most other machines usually also come by default with really cheapy made hold downs, and they don't have the counterweight, causing you to hold down your part not securely. The counter lever here is something essential. These are some of the much nicer clamps I've seen on these machines. I still need to try out the pyramid bits a little bit more. I use these on the aluminum plate here, but the feed rate was too high. So in a coming video, I'll show how that comes out, hopefully a little bit better. Now, I tried to be as thorough and detailed as possible in this video. I apologize if it's been too long to bear for some people, but I want to make sure that if there were any issues, that hopefully you could find the answers in this video. I hope it has been a big help to you. It's been a big learning experience for me. You definitely have to have patience with this machine. I've made a few mistakes. You have to understand the limitations of the machine. Since it's on linear rails, everything has give. But honestly, that give is good, because a few times I've already crashed the machine, and luckily that give prevents stuff from breaking. Because if you had a much more rigid machine with much more power, you could really do a lot of damage. Here, so far everything's still good.